In this section, we're going to talk about solving equations that have radicals in them. And sometimes when you solve an equation that has a radical in them, and sometimes this happens with rational equations as well, you get something that's called an extraneous solution. And an extraneous solution is an answer that you get as a consequence of trying to solve that equation. However, that answer doesn't necessarily always work when you plug it back in to check to see if it gives you a true statement. So if you get an answer that's a result of solving an equation, but it doesn't work in the original equation that you get, that is called an extraneous solution. And that happens a lot with radicals and rational equations. So when we have a radical equation, in these examples here, we want to make sure that we go back and always check our answer. Okay, now in the first example, we have 5 equals the square root of 4x minus 3. If you don't see a number here that tells you what root it is, then you can assume that it's the square root. Otherwise, you'll see a 3 or a 4 there for cubed root or fourth root. Okay, so when we are solving an equation with radicals in them, the tools that we want to use is you want to, if you're using the square root, you want to square it because the square and the square root undo each other. They're inverses. So that's how we can get rid of the square root. Now, if it was a cubed root or a fourth root, then you want to either raise it to the third power or raise it to the fourth power so that you can undo that root. But in this case, we're dealing with square root, so we're going to square both sides. Before you square both sides, though, it's really important that you isolate and get that square root by itself. So here's my square root, and it's by itself. So that's the first step. Okay, once you get the square root by itself, then you can square both sides of the equation. Whatever I do to one side, I have to do it to the other side. So I'm going to square this side, and I'm going to square this side. So on the left-hand side, I have 25. On the right-hand side, I have the square root of 4x minus 3, and that's squared. So the squared and the square root undo each other, and I'm left with just 4x minus 3. And now this makes it a lot easier to try to solve for x. All right, so now we got rid of the radical, and it comes down to a linear equation, which is easy for us to solve. I'm just going to add 3 to both sides. That gives me a 28 is equal to 4x, and then I'm going to divide both sides by 4. So I get x is 7. Because this is a radical equation, and sometimes we can get an extraneous solution, we want to make sure that we check our answer. So we're going to plug 7 in everywhere I see x in the original equation. So my original equation is 5 and then the square root of 4x minus 3. So I'm going to put a 7 where that x is. So that gives me 5 is equal to 4 times 7 is 28. So I get 5 is equal to 28 minus 3, which is 25, and the square root of 25 is 5. So that works. 5 is 5. So this is our answer. Okay, the next example, the square root is not isolated. I want to get this, the square root of 2 minus x, by itself. So I'm going to first subtract 1 from both sides. And now I'm going to divide both sides by -1 to get rid of that negative that's in the front. So that makes it a +1 and a minus 2x. Because I divided both sides by -1. Okay, now that the square root is isolated, I got this all by itself on one side. I can go ahead and square both sides now. So I have 1 minus 2x squared is equal to the square root of 2 minus x squared. So this becomes here just 2 minus x because the square root and the square undo each other. Now, something to keep in mind, because I see a lot of students make this mistake, make sure that you don't just write down 1 plus 4x squared for the left-hand side, because 1 minus 2x squared means 1 minus 2x times 1 minus 2x, and you have to use the distributive property twice. Okay, so I'm going to do 1 times 1, that gives me 1. And then 1 times a minus 2x gives me a minus 2x. And then a negative 2x times a 1 is a minus 2x. And then the negative 2x times the negative 2x is a positive 4x squared. And that's all equal to what's on the other side, which is 2 minus x. Okay, now, if I write this in descending order and move everything to one side, I'm going to have 4x squared. The minus 2x and the minus 2x gives me a minus 4x. And then I'm going to add an x to both sides. So that's going to give me a minus 3x. And then I have a 1, and I'm going to subtract the 2 from both sides. And that's going to give me a minus 1. So I combined a few things in this step. I put it in descending order and combined like terms, and I put 0 on the other side. I kind of did that all at once. If you can't do that in your head all at once, write out a couple extra steps. Okay, now let's factor. This is a quadratic equation. So in our toolbox, we have factoring, quadratic formula. This one will factor, and my preference is to factor, so I'm going to do that. If you don't like factoring, you can use the quadratic formula. You should still get the same answer that I get. So when I factor this, I'm going to get 4x and x. That gives me the 4x squared. And then I'm going to get a minus 1 and a plus 1. Then I'm going to set each of those factors equal to 0. And that gives me x is minus a fourth and x is 1. Now, when I go back in and check those two answers, you're going to find that this does not work. The 1 doesn't work. However, when I plug the negative 1/4 back into the original equation, that does work. So we would say that x equals 1 is an extraneous solution. Our only solution is x is equal to negative 1/4. Next example, example 3. Again, we have to isolate that square root before we can square both sides. So we're going to subtract 3 from both sides and add the square root of x minus 1 to both sides. So now we've isolated the square root. Now that I've isolated the square root, I can square both sides. So I have x minus 3 squared is equal to the square root of x minus 1 squared. This gives me just x minus 1 because the square root and the square undo each other. And I'm just left with what's underneath. And then the x minus 3 squared, don't forget, that's FOIL. That's x minus 3 times x minus 3. Okay, when I FOIL that, I'm going to get x squared minus 6x plus 9. I did a couple steps in my head. If you can't do that, write out all the steps. Okay, now I have a quadratic equation, and I want to get 0 on one side and everything else on the other so I can finish solving this. So I'm going to subtract x on both sides, and I'm going to add 1 to both sides. This one does factor as well, and since my preference is to factor, I'm going to go ahead and do that. If you don't like factoring, you can use quadratic formula. So I have x minus 5 and x minus 2. So my two possible solutions are 5 and 2, but because this is a radical equation, we have to check for extraneous solutions. And you'll find out that when you go back and check, the 2 does not work. And our only answer will be x is equal to 5. So 2 is considered an extraneous solution. Okay, last example, and this one's a little bit messy because we're going to have to square things 2 times. It's not any harder, it's just a little bit longer and a little bit messier. Okay, because I have 2 radicals here, it's hard to isolate the one radical before we square both sides. So I'm just going to jump in and start squaring. There's nothing we can do to clean this up. So I have the square root of 3x plus 1 is equal to 2 plus the square root of x plus 1. Whatever I do to one side, I have to do it to the other side. So this square root here and this square undo each other, and I'm left with 3x plus 1. This is where it gets a little bit messy, is because we have to FOIL with radicals. So I have 2 plus the square root of x plus 1 times 2 plus the square root of x plus 1 because it's squared. And I have to FOIL that. So I have 2 times 2, that gives me 4. Then I have 2 times the square root of x plus 1, so that gives me 2 square roots of x plus 1. Then I have this times this, and I get 2 times the square root of x plus 1 again. And then this times this gives me just x plus 1. So now that we FOILed out the 2 plus square root of x plus 1 squared, now let's clean this up and combine like terms. So I have the 1 and the 4, that gives me a 5. So I have 3x plus 1 is equal to 5. And then I can combine these 2 square roots. I have 2 square roots of x plus 1 and then another 2 square roots of x plus 1, which will give me a total of 4 square roots of x plus 1. And then I still have this x here. So I still have this square root here. So I'm going to have to square this one more time, which means I have to isolate the square root first. So I'm going to get everything to the other side and get that square root of x plus 1 by itself. And we're going to repeat the process one more time. So again, this isn't hard. It's just kind of long and messy. Okay, so I'm going to subtract x from both sides. So over here, I'm going to have a 3x minus x. So that's going to give me a 2x. And then I'm going to subtract 5 from both sides. And that's going to give me a minus 4 is equal to 4 square root of x plus 1. And now I'm going to divide both sides by 4. So I'm going to have 1/2 x minus 1 is equal to the square root of x plus 1. So now I have that square root isolated, and I'm going to do this one more time. I'm going to square both sides. Kind of running out of room here. So I have 1/2 x minus 1 times 1/2 x minus 1 is equal to, and then the square root of x plus 1 squared is just x plus 1. Now, when I multiply that out, if you can't do these multiple steps in your head, that's totally fine. So just write out a couple extra steps. But I'm going to FOIL the 1/2 x minus 1 times the 1/2 x minus 1. And I'm going to get 1/4 x squared minus x plus 1 is equal to x plus 1. I'm going to get everything to one side. So I have 1/4 x squared. I'm going to subtract x from both sides. So that gives me a minus 2x. And I'm going to subtract 1 from both sides. So those disappear and give me 0. And now we're down to where we can just factor and find our answer. So I'm going to pull out an x. So I'm going to get x is equal to 0. That's the first factor. Set each factor equal to 0. And then I have 1/4 x minus 2 is equal to 0. This has already solved itself. When I solve this for x, I add 2 to both sides and multiply by both sides by 4. So I get x is 8. Now, when we plug it back into check, because this is a square root problem, we always want to make sure we check our answers to see if we have an extraneous solution. When you go back and check, you're going to find that 0 doesn't work, but x equals 8 does. So x equals 0 is an extraneous solution, and our only answer to this is x equals 8.